Hey, Dr. Clark coming back at you with another differential equations check your understanding video. We're in section 3.3, which is about modeling using systems of differential equations. Let's take a look at the problem they've given to us here. It looks to me like we've got a tank mixing problem, so pretty classic tank mixing problem where you basically have, two tanks and one tank kind of dumps into the other one and that tank dumps back into that one, and maybe there's some water flowing in and some water flowing out, and you got to kind of model all the different flows and make sense of the problem that way. Okay, so let's read it and see if we can work this one out. So we got two well-mixed tanks connected via pipes that allow mixing between them. A is the mass of salt in tank 1. B is the mass of salt in tank 2. Using the following information, create a model of the system. Okay, so we do not need to solve this. Sometimes you write the model and then you need to solve it to answer a question. In this case, they are only asking us to create the model. And the model should be differential equations, in this case 2 because it's going to be a system, and initial conditions. So what our model should eventually look like is dA dt, the mass of salt in tank 1, dB dt, the rate of change of mass of salt in tank 2, the initial salt in tank 1, and the initial salt in tank 2. That is a model. It's the set of differential equations together with those initial conditions here. All right, so brine with concentration 2 grams per liter is pumped into tank 1 at a rate of 3 liters per minute. Okay, so how many grams of salt are coming into tank 1? Well, the concentration is 2 grams per liter, and the flow rate is 3 liters per minute. So that, if I look at that, that looks like 6 grams per minute of salt coming into tank 1, and that is a rate. And if you look right here, right, dA dt, that is a rate, right? Mass per minute, right? And grams per liter is mass per minute. So the units make sense. Sometimes the units help you. So I'm going to have just a constant 6 grams per minute being pumped into tank 1 with this brine that comes in. Okay? All right, now tank 1 is pumped into tank 2 at a rate of 5 liters per minute. So if we want to do the same kind of thing here, we would need the grams per liter in tank 1 times 5 liters per minute in tank 1, pumping into tank 2. But how many grams are there inside of tank 1? Well, there's A grams inside of tank 1. And how many liters are in tank 1? That's a good question. So this is going to be minus A divided by the volume of tank A. That's grams per liter, times 5, or maybe I can write this as times 5, right? And that's liters per minute. So if I clean that up, we're going to have basically minus 5A over whatever the volume of tank A is. Okay? And that's coming out of A and it's going into B. So I'm going to have a 5A over the volume of tank A right there. So what is the volume of tank A? Well, let's see. It has 500 liters of water in. Okay, so it could be 500, but it's changing, right? So let's think about this. How much comes in? We've got 3 liters per minute right here. We got 3 liters per minute coming in. We've got 5 liters per minute going out from tank 1. But then we've got 2 liters per minute coming from 2 back into 1. And that's 0. So the change is 0. So volume of tank A is just holding steady at 500. Okay? Because it's 3 in, 5 out, 2 in. So the change is 0, so it's going to stay at 500. So volume of A is going to just hold at 500. So I'm going to just write 500 where I had the volume of tank A. 500 and 500 there. Okay. All right, let's keep going. So I think we've handled this one. We have handled this one. Now tank 2 is pumped into tank 1 at a rate of 2 liters per minute. So there's going to be from tank 2 a minus however many mass per whatever the volume of tank B is times 2, right? And that's going to come into tank 1. So this 2B over the volume of tank B, maybe I can write that as 2B right there as well. That'll clean that up a little bit. So 2 liters per minute, B liters per liter, or B mass per liter. But what is the volume of tank B? Okay, so it says it's 400 right here at the beginning. It's 400 liters at the beginning, but it's changing. So what is the change? It is, well, let's see. It's 5 liters are coming in from tank 1 to tank 2. 2 liters are coming out from tank 2 into tank 1, and then 4 liters right here are coming out per minute. So that, what does that add up to? A change of negative 1 liter per minute. So if it starts at 400 and it's losing 1 liter per minute, that's minus 1 liter per minute, right? It's just going to be 400 minus T. It's going to drain down, right? Over 400 minutes, it's eventually going to get down to 0 because it's losing 1 liter per minute. So volume of tank B is 400 minus T. So I'm going to fill that in right here. 400 minus T and 400 minus T. So however much salt there is in tank B, that salt is dissolved in 400 minus T liters of water. Okay? So now we've used this equation, or that piece of information. It says that tank 2 is drained at a rate of 4 liters per minute. So I'm going to lose salt in that draining as well. I'm going to need to make a little bit more space here for myself. Let me just kind of adjust this. So I'm losing 4 liters per minute times B grams per liter. How many liters? 400 minus T. And I guess you could have just said 2 liters here, 4 liters here. I'm losing 6 liters. So, you know, you could combine, if you wanted to, you could combine those two terms into a 6B. I'm just going to leave it because it's sort of coming from two different pieces of information. But what's interesting is this one shows up here and here, whereas this one only shows up here because it's just being drained. It's not going into anything. It's just being lost. So that's kind of an interesting feature. These terms are paired. These terms are paired because it's the pump is going back and forth. This is just lost. All right, and then I just need my initial conditions down here. So 5 grams per liter, 500 liters. That sounds like what? 2,500 grams. 3 grams per liter, 400 liters. That sounds like 1,200 grams. And now I've got my initial conditions. So that is my model. All right, so hopefully you were able to construct this model. A couple of tricky points here. But if you're able to kind of read the information and reconstruct the model, that's excellent. Give yourself some comments. What did you understand? What was hard? What was easy? And then give yourself a grade. How well did you do on this problem? And then use that information to kind of either make you feel good about your success or figure out, maybe if you need to do a little more study or not. All right, we'll see you next time.